Hi everyone, welcome to this video of PyNet Labs. My name is Dhcp and I am here to discuss the assignment which was posted in the Telegram group of PyNet Labs. This assignment was a part of $100 giveaway. So if you too want to participate in such giveaways, make sure you join the Telegram group from the link given in the description. So let's get started without wasting any time. I welcome you all again and let's see what do we have in this assignment to do. Alright, so this is the assignment which was posted last week and it says that configure the topology given below and fulfill the requirements given in the task. So this is the assignment number 1 and the tasks which are given to us are that it says that design the topology and configure IP addresses. Then it asks you to change the host names of the routers, then configure the dynamic routing protocol RIP to make all the networks communicate with each other. Then lastly, it asks you to configure DHCP relay agent by creating router number 2 as the DHCP server. So let's get started. Let's see how can we solve this requirement of this particular assignment.
If you enjoyed the content of the video, don't forget to like and share the video and subscribe to our channel.
So I have this topology ready with me in the packet tracer. So let's quickly get started with the configurational part and see how do we have to solve this assignment. So I'll go to this R1 and in the CLI we will start making the configurations. So the first task is to assign IP address to all the devices. So let's get started. Let's configure the routers with their respective IP addresses. I'll press enter, then I'll say enable config T. I'll change the host name to PyNet1. Then we will start configuring the IP addresses on the interfaces. So on interface FA0/0, I'll assign the IP address 12.001 with a subnet mask of /30, which is 255.255.255.252, and then no shutdown. Exit. Then interface FA0/1 will have the IP address 13.001 255.255.255.252 and no shutdown. And take an exit again. Interface FA1/0 will have the IP address 192.168.1.1 255.255.255.224 because it is there with the subnet mask of /27. Enter and then say no shutdown. Take an exit. Then the next task is to configure the rest of the routers. I'll go to router 2. There I will start the configuration. I'll say enable config T. Let's change the host name to PyNet2. Now on interface FA0/1 we will have the IP address 12.002 255.255.255.252. Then let's say no shutdown. And on interface FA0/0 also we will have the IP address 23.002 255.255.255.252. No shutdown. Then lastly on interface FA1/0 we will have the IP address 192.168.3.1 255.255.255.224 as it is there with the subnet mask of /27. Then no shutdown. Now take an exit. Now it's time to configure the router number 3. Let's go to router number 3. I'll say enable config T, change the host name to PyNet3. Then on interface FA00 I'll assign the IP address 13.002 255.255.255.252 and no shutdown. On interface FA0/1 we will have the IP address 23.001 with a /30 subnet. Then finally on interface FA1/0 we will have IP address as 192.168.2.1 255.255.255.224. Then no shutdown. Now we are done with the first two tasks, and it's time to get to the third task, which is given in the assignment. Let's check what it is. So we have successfully configured the IP addresses, we have given the correct host names. Now it's time to configure the RIP so that all these networks can communicate with each other. So we will start the configuration of RIP now. Let me open the packet tracer there. So let's begin the configuration of RIP here from R1. Now we need to understand that the networks which we are using here are not there with their default subnet mask. So that means we cannot use RIP version 1 as it doesn't support classless routing, right? So we'll be using RIP version 2 on the router number 1, router number 2 and router number 3, and we will advertise the directly connected routes of these routers. So I'll go to this router number 1, we'll start configuring RIP here. So we will say router RIP, we'll define the version as version 2, say no auto summary to disable the feature of auto summarization. No auto summary. Now it's time to advertise the directly connected routes. So network 12.0.0.0, similarly network 13.0.0.0, and then network 192.168.1.0 exit. That's all. Now we will go to router number 2, and there also we will put the RIP configurations. Router RIP version 2, no auto summary, network 12.0.0.0, network 23.0.0.0, and network 192.168.3.0 exit. Then on router 3 we will say router RIP version 2, no auto summary, network 192.168.2.0, network 13.0.0.0, then network 23.0.0.0 exit. We have successfully advertised the directly connected routes in the RIP domain, and let's check the routing table of R1 and see if we are receiving the RIP routes or not. I'll say end show IP route to check the routing table, and we can see there are some routes there in the routing table which are learnt via RIP. So there is a RIP route towards 23.0.0.0/30. So since we have used version 2, that is the reason we are getting it as a /30 route. Otherwise, if we, let's say, configured it with version 1, then the route will be received with the default subnet mask. That means this route would be there but with a /8 subnet. So in such cases, when your networks are with the modified subnet mask or are with the CIDRs, so make sure you are using the version 2 and the configurations are correct. Similarly, if you check, the subnet mask of 2.0 and 3.0 is /27. So we can say that we have successfully configured RIP on all the devices, and if we check the routing table of R2 also, we will find the RIP routes there. We have the RIP route towards 13.0.0, we have it towards 1.0, then we also have it towards 192.168.2.0. Now the last task of the assignment says configure DHCP relay agent, creating R2 as the DHCP server for all the networks. So we have to configure a centralized DHCP server on R2 so that the other networks like 192.168.1.0 and 2.0 can get the IP address from router number 2. So let's go to router number 2 and put the DHCP configurations there. So in this router I will be creating 3 DHCP pools, one for 192.168.1.0, then for 2.0, then for 3.0. So I'll say config T IP DHCP pool A for the network 192.168.1.0, 255.255.255.224, and the gateway will be 192.168.1.1. Take an exit. Then IP DHCP pool B for the network 192.168.2.0, 255.255.255.224, and the gateway here will be 192.168.2.1. Take an exit. Then lastly, IP DHCP pool C for the network 192.168.3.0, which is directly connected to this router. So 192.168.3.0, 255, 224, and the gateway will be 192.168.3.1 exit. I have created all the pools, and if I try to assign IP to now PC4 and PC5, let's see if we get the IP address or not. We are receiving the IP address. DHCP requests are getting successful. Similarly, on PC5 also, I got the IP 192.168.3.3, and there is the correct subnet mask, correct default gateway. Now, if I go to PC0, let's say, but try to get the IP using DHCP, I will not get the IP address. And the reason behind that is that we haven't informed R1 to ping R2 in order to get the IP. I mean, R1 doesn't know that it has to reach out to router number 2 to get the IP address for the network connected to R1, which is 192.168.1.0. So we'll go to R1, we will configure the IP helper address command, and then after that, if we try getting the IP address using DHCP, that request will get successful. So config T on interface FA1/0, which is connected to the LAN here on router number 1, I will say IP helper address, and will configure any IP which is there on router number 2, because all of them are reachable now with the help of rep. So I'll say 12.002 and exit. Similarly, on router number 3 also, I'll go to interface FA1/0 and I'll configure IP helper address 12.002 exit. After doing this, if I try getting the IP using DHCP on PC0, we can see that the request is already successful. We have got the IP 192.168.1.2, the subnet mask is there, the gateway is there. If I go to PC1, desktop IP, put DHCP, we are receiving the IP address. Similarly, on PC2 and 3 also, you will get the IP. Perfect. Now let's also check the connectivity between devices. I'll go to this PC0 and we'll try to ping the devices from 192.168.2.0 network and 3.0 network. So I'll say ping 192.168.2.2. Okay. Alright, then we are getting the reply, right? That means the communication is there between devices. Then if I try to ping 192.168.3.2, let's see if we get the reply or not. Amazing. So we are receiving the replies. The routes are, because they are in the routing table of routers. Then we can say DHCP is also working fine. R2 is my centralized DHCP server. I have successfully changed the host names of the devices as it was asked in the assignment. So now I can assume that I have successfully completed the assignment correctly and I can submit it as per the template. So I hope you guys enjoyed the video and got to learn out of it. I suggest you all to make sure you participate in such giveaways, as it not only helps you to get the prize money but will also help you to brush upon your skills on these protocols. So all the best guys. I hope you enjoyed the video. Thank you so much for your time. Take care. Bye bye.